I have to start. I cannot wait. All right. Let us to repeat the idea in the previous class that we have discussed. The last thing where we stopped last time, it was at the Bernoulli equation. At the Bernoulli equation. And as we said, the Bernoulli equation is the equation which is written in the form. The Bernoulli equation is the equation which is written in the form dy by dx plus pxy is equal f of x to the power y to the power n. N is any real number, not necessary to be integer or a positive. It's just any real number. It could be rational or irrational. الآن, how we can solve the Bernoulli equation? Let us to repeat again the procedure of solving the Bernoulli equation. The first thing I have to assume it for Bernoulli equation, I have to rewrite my equation in its standard form. I mean this is standard form. This is the standard form of Bernoulli equation, which means the coefficient of dy by dx, it should be 1. Now, the second step, I have to assume u to be y to the power 1 minus n. الآن, in this case, I have to find du by dx, which is equal 1 minus n phi y to the power minus n times dy by dx. الآن, for this equation, I will call it star. This is step number 1. Step number 2, divide. The equation is star by y to the power n. You will get the equation y to the power minus n phi dy by dx plus px times y divided by y to the power n is equal f of x, which implies that y to the power minus n dy by dx plus px times y divided by y to the power n, it is y to the power 1 minus n is equal f of x. Now this term here, y to the power 1 minus n, this one here, it is u. But now, y to the power n minus 1 times dy by dx, you can get it from here. Therefore, y to the power minus n dy by dx is equal 1 divided by 1 minus n times du by dx. Then in this case, you can rewrite your equation to be 1 over 1 minus n times du by dx is equal px times u is equal f of x. And you can solve it by linear, which implies that du by dx plus 1 minus n times px times u is equal 1 minus n times f of x, which can be solved by either linear or separable. I mean, this equation here, it becomes now a linear or separable, but with respect to u and f of x, u and x. We have done one example last time. Let us to do the rest of the examples, and we will continue, inshallah, for the last chapter of section of chapter 2. Hello, the question says solve t square dy by dt plus y square is equal ty. الآن, for this example here, the dependent variable y will independent variable is t. dependent y, well, independent variable is t. The first thing before we doing anything, I have to divide both sides by t square because I need it in its standard form. So this is becomes dy by dt plus 1 by t squared times y square is equal t divided by t squared, which means that you have to solve dy by dt plus 1 by t squared times y squared is equal 1 by t times y. This equation is Bernoulli with the value of n is equal 1. The value of n is equal 1. But, sorry, is equal 2. Because this one here, it can be written as dy by dt minus 1 by t times y is equal minus 1 by t square for y square. So this one here is Bernoulli with n is equal to. الآن, the first step I have to do it, I have to divide both sides by, yes? Yes, Bilal?
Professor, the n value is just the power, yes? Yani power of t, right?
Again, your question? n is
So
the power of
value,
y. N is the power of y here.
okay, so sir, why are we using t square multiplied by dy by dt? I thought we did multiplied by just t to the power 1 in the previous lecture.
No. And it was 2, the same thing. And have a look
Okay,
here.
sorry.
What I have to follow me this example, you will understand the idea very well. The first thing you have to do is divide both sides by y squared, becomes y to the power minus 2 dy by dt minus y by t divided by y squared is equal minus 1 by t squared, which implies that y to the power minus 2 dy by dt minus 1 by t, 1 by y is equal minus 1 by t squared. Now you have to assume u to be y to the power 1 minus n, which is y to the power 1 minus 2, which is y to the power minus 1. الآن, now find du by dx. It is minus 1 times y to the power minus 2 dy by dt. Sorry, here the independent variable, not x, it is t. الآن, in this equation here, you have y to the power minus 2 dy by dt. So, du على dt, you have to multiply it by negative to get y to the power minus 2 dy by dt. So that means minus du على dt is equal y to the power minus 2 في dy by dt. Now, let us to rename this is equation number 1. Now, equation number 1 becomes, replace y to the power minus 2 dy by dt by its value, minus du by dt minus 1 by t. Hello, 1 by 1, it is u, because it is y to the power minus 1. For u is equal minus 1 by t squared. And this equation here, multiply the whole equation by negative, so you will get du by dt plus 1 by t, u is equal 1 by t squared, which linear equation? I mean linear differential equation, which is a linear differential equation. Now you have to solve it, but how? I will continue solving here, but this example I will take it in another page. Ilam, how you will solve the linear? Here for this linear you have P of t is equal 1 by t. F of t is equal 1 by t square. You have to find the integrating factor mu of t, which is e to the power integral P of t la dt, which is e to the power integral of 1 by t la dt. And that becomes e to the power ln absolute t, which is equal absolute t, and that is equal t where t should be greater than 0. Now the solution u of t is equal 1 by mu of t times c plus integrating the factor of mu t times f of t, the dt. This is the method of finding the solution for linear, which is equal 1 by mu of t, it is t, so 1 by t times c plus integral mu of t, which is t, times f of t, it is 1 by t square. Well, that becomes 1 by t times c plus integral 1 by t la dt, which is equal here 1 by t times c plus ln of t, because we assume t is greater than 0. And this is becomes c على t or c plus directly ln of t divided by t. Now have a look here. What we have done, it is just only mu of t, u of t, sorry. But y to the power minus 1 is equal u of t, which is c plus ln t divided by t. That means the solution y is equal reciprocal t divided by c plus ln t. And this is explicit solution. Any question for this example? Any question here؟ في أي سؤال على هذا المثال برنولي؟ Procedure is straightforward and very simple. All right. We do not have initial condition here. No. So this is the solution of my original differential equation. Right. I will put another page to solve that question where we still it is space. سرقنا المساحة تبعته. The next example says that solve the initial value problem y to the power half dy by dt. I think x, yes, dy by dx plus y to the power 3 by 2 is equal 1, where y of 0 is equal 4. Again, I have to write it in each standard form. So the standard form for this equation is I have to divide by y to the power half. Divide by y to the power half. طيب الآن بصير معنا الستاندرد فورم dy by dx plus
y to the power 3
2 divided by y to the power half is equal 1 by y to the power half. All right, type, which is equal dy by dx plus y to the power 3 by 2 divided by y to the power half. It is y is equal y to the power minus half. So this is standard equation. This one here is Bernoulli with n is equal minus half. الآن I have to take u. What's the value of u here? I have to take it. شو قيمة u اللي بدي هون أخذها؟ Then u is equal y to the power 1 minus n, which is y to the power 1 minus half, and that's y to the power 3 by 2. Now find du by dx, which is 3 by 2 for y to the power 1 times dy by 3 by 2, yes, dy by dx. Okay, to the power half here, sorry, because of 3 by 2 half. الآن that means 2 by 3 times du by dx is equal y to the power half times dy by dx. Now for this equation here, divide both sides by y to the power minus half, becomes y to the power half dy by dx plus y على y to the power half is equal 1, which is equal, implies y to the power half dy by dx plus y to the power here minus half, 1 minus half is equal 1, and that becomes y to the power half dy by dx plus y to the power 3 by 2 is equal 1. But you have here y to the power half dy by dx is equal 2 by 3 du by dx. So replace it. So this becomes here 2 by 3 du by dx plus y to power 3 by 2, it is already u, is equal 1. Now write it linear in its standard form, becomes du by dx plus 3 by 2 times u is equal 3 by 2. Now this equation here is linear. Linear equation. هلا p of x is equal 3 by 2 و f x is equal 3 by 2. I have to solve it as a linear. Find the integrating factor mu x is equal e to the power integral px dx, which is e to the power integral 3 by 2 dx, which is e to the power 3 by 2x. الآن السوليوشن u, because my dependent variable here becomes u of x becomes 1 by mu x times c plus integral mu x times f of x dx. 1 by mu يعني 1 by e to the power 3 by 2x times c plus integral e to the power 3 by 2x times 3 by 2 which is f of x dx. هلا الانتجرال ل e to the power 3 by 2x شو بده يساوي times 3 by 2 في c plus it is e to the power 3 by 2x, and that becomes c p e to the power minus 3 by 2x plus 1. This is ux. But how much is u equal? U equal y to the power 3 by 2. Y to the power 3 by 2 is equal ux, which is equal c p e to the power minus 3 by 2x plus 1. I think I need another page here. طب نكفي المسألة الآن. That means y to the power 3 by 2 is equal c e to the power minus 3 by 2x plus 1. طيب, how you will find the value of u? But remember, you have an initial condition y of 0 is equal 4. هلا substitute it to get, instead of y replace 4, and instead of x replace 0. Means 4 to the power 3 by 2 is equal c p e to the power 0 plus 1, which is equal c plus 1. الآن ال 4 to the power half to the power 3 بده يساوي c plus 1, which is implies 4 to the power half, it means 2 to the power 3 is equal plus 1, that means 8 is equal c plus 1, where c is equal 7. إذن الآن go back to your solution, substitute c here. Y to the power 3 by 2, that's how c v to the power minus 3 by 2x plus 1 is c, replace it by 7. To get y, take the power 2 by 3, which is 1 plus 7 e to the power minus 3 by 2x to the power 2 by 3. This is the final solution for that differential equation. Any question here for this example? Any question? Bernoulli is very simple and straightforward. All right, no question. Go to the last type of the differential equation. We have the third type of the substitution method for the differential equation, which is in the form, or written in the form, dy by dx is equal f of ax plus by plus c. Ax plus by plus c, it is linear of two variables. Linear because the power of x1, the power of y1, which is the maximum power here. طيب الآن how we can solve such kind of differential equations? To solve such kind of differential equations, you have to assume u to be the linear with two variables, ax plus by plus c. Then this implies that du by dx is equal a plus b times dy by dx. All right. طيب الآن take a to the other side, becomes du by dx minus a is equal b times dy by dx. Divide by b becomes dy by dx is equal 1 by b times du by dx minus a. So this differential equation now becomes, when you after this substitution, replace dy by dx by its value, 1 by times du على dx minus a is equal f of u. Then you will solve it, in this case, either separable or linear. Separable or linear. The method is very simple and straightforward. خلينا نشوف الاكزامبل. الاكزامبل بيقول لي solve the following initial value problem. You have dy by dx is equal minus 2x plus 2 to the power 2 plus 7. So what you will take u here, it is this linear. It is minus 2x plus y. Find du by dx is equal minus 2 plus dy by dx, which implies that dy by dx is equal du by dx plus 2. And then this equation here now becomes, replace dy by dx by du على dx plus 2 is equal to u square plus 7. Take it 2 to the other side. خذ u to the other side. Becomes du by dx is equal to u square plus 5. Now you can solve it as separable differential equation, which means 1 by u square plus 5 times du is equal 1 times dx. Now integrate both sides. شو بدي يعطيني؟ الانتجرال 1 by u square plus square root of 5 square ل du is equal integral 1 times dx. طيب, the right hand side it is x plus c, but how we can integrate the left hand side? We have a formula says that the integral for 1 by x square plus a square ل dx is equal to 1 by a tan inverse x by a plus c. So here becomes 1 by square root of 5 tan inverse u divided by square root of 5. Multiplied both sides by square root of 5 becomes tan inverse u على square root of 5, but this is square root of 5 times x plus another constant c1, such that c1 شو بدي يساوي معي؟ square root of 5 times c. الآن take tan for both sides. Becomes tan of tan inverse will go. Here you will have u divide by square root of 5 is equal tan of square root of 5 times x plus the constant c1. So the value of u here becomes square root of 5 times tan square root of 5 times x plus the constant c1. Replace u. What's the value of u here? شو هي قيمة اليو؟ It is minus
2x plus y.
exactly. Replace it back. الآن minus 2x plus y is equal u, which is square root of 5 tan square root of 5x plus c1. Take a minus 2x to the other side, becomes y is equal 2x plus square root of 5 times tan inverse square root of 5 times x plus c1. Now you have to find the constant. The initial condition y of 0 is equal 0. Here, this is the solution. Now, to find the constant, replace y 0 or x 0. Y of 0 is equal 0 implies إنه 0 بده يساوي 2 times 0 square root of 5 tan of 0 plus c1. هلا tan of c1 is equal 0. That means what? c1 is equal 0. Substitute c1. That becomes y is equal 2x square root of 5 tan inverse square root of 5 x only. Any question? في حد بلال تفضل يا بلال.
Yeah, Professor, isn't it tan and not tan inverse? Because if we look at the working out, it's root 5 tan 5x plus c1. Just to the left of the box. You know, you made the box?
Yeah, the right. Yes.
Yeah, in that same line.
You mean
on the
integral
left.
1 by x squared plus a square? You mean here?
No, sir. Come down. In the bottom line, you know, last line of the page, you made the
Yes.
box in with the blue line. Yeah, to the left, you wrote the
Blue
equation.
line. Yes.
Yeah. Okay. So the equation is minus 2x plus y equals u, which equals to root 5 tan inverse of 5 root 5x plus c1. So doesn't that mean that y equal to 2x plus root 5 tan of root 5 plus c1, not tan inverse?
You mean here it's a typo. Okay. Yeah, it is here, 10. Thank you. Here, 10. Any question here?
Thank you.
Thanks. All right, next example. You're going to solve the following initial value problem. What's the linear of x or y that you can substitute it here? It is clear that x is equal x plus y, u is equal x plus y. Therefore, du by dx directly is equal 1 plus dy by dx, which implies dy by dx is equal du by dx minus 1. So this equation here becomes now du by dx minus 1 is equal cosine u, which implies du by dx is equal 1 plus cosine u. Now it is separable. This equation here, it is separable. Therefore, 1 by 1 plus cosine u times du is equal 1 times dx. How we can solve this one? الآن الانتجرال for 1 plus 1 plus cosine u du is equal integral 1 times dx. This equation implies that to integrate 1 by 1 plus cosine, if you remember in calculus 2 in section 8.1 in example number 5 in my lecture notes, you will see this one exactly integrated there. You have to multiply by its conjugate, which is 1 by 1 plus cosine u times 1 minus cosine u على 1 minus cosine u is equal integral 1 by dx. It is x plus c. الآن to integrate the left hand side, it becomes integral 1 minus cosine u divided by 1 minus cosine square u. هلا 1 minus cosine square here at the denominator, it is a sine square. The du is equal x plus c. Now you have to separate because the numerator it has two terms. Comes integral 1 by sine square u du minus integral cosine u على sine square u du, which is equal x plus 1. الآن الانتجرال 1 by sine square, it is integral of cosecant square. مش هيك؟ which is integral cosecant square minus integral cotan cosecant. This becomes integral of cosecant square u minus cosine divided by sine, it is cotan. Then you will have left over 1 by sine, which is cosecant u. The du is equal x plus c. طيب الآن what's the integral of cosecant square? It is minus cotan u. الانتجرال minus cosecant cotan, it is cosecant is equal x plus c. Now replace u back by its value, which is x plus y. نستبدلها, becomes minus cotan x plus y plus cosecant x plus y is equal x plus c. But here we have y of 0 is equal pi over 4. So replace each x, but y of 0 is equal pi over 4. Replace each x by 0, each y by pi over 4, becomes minus cotan is 0 plus pi over 4 plus cosecant is 0 plus pi over 4 is equal plus 0 plus c. هلا cotan الباي over 4 it is 1 multiplied becomes minus 1 plus cosecant الباي over 4 اللي هي square root of 2. Now replace back in this equation here is the solution. Replace back C. It becomes cosecant x plus y minus cotan x plus y is equal x minus 1 plus the square root of 2. And that's all. Is it clear؟ واضح لحد الآن؟ Any question for this example? All right. نشوف the next example. For sure I need an extra, at least one extra. The example says dy by dx is equal to 1 minus x minus y divided by x plus y. يا عبد الغني, yes. Here you have to you assume in this method u to be the linear of two variables x and y. Right. First of all, notice that this equation here can be written as dy by dx is equal 1 minus of x plus y divide x plus y. Then what's the best u substitution to take it here? You will have to take u to be x plus y. Then du by dx becomes 1 plus dy by dx, which implies dy by dx to be du by dx minus 1. So this equation now again here becomes, replace dy by dx, du على dx minus 1 is equal 1 minus u divided by u, which is equal 1 by u minus 1. Take this minus 1 to the other side, so you will have finally du by dx is equal 1 by u minus 1 plus 1, because I took this minus 1 on the left hand side to the other side. So that means becomes du by dx is equal 1 by u. Therefore, here you have to what? Separate, because this is separable. u times du بتساوي 1 times dx. Integrate u ل du integral 1 times dx, which is equal half u square is equal x plus c, x plus c. And multiplied by 2, this becomes u square 2x plus c1. c1 is equal to c. And replace u back. What's the value of u? X plus y. So x plus y square becomes 2x plus c1. So this is the solution. Is equal x plus y squared is equal to x plus c. واضح المثال هذا؟ Just clear this example. All right. By this example, we are finishing section 2.5.